Hi, good evening, friends. On behalf of Mindtree Training Institute and KPR Institute of Technology, I would like to extend a very warm welcome to those parents and students who are attending today's webinar. Today's webinar topic is going to be on mechanical engineering, skills and opportunities for 21st century engineers. We are happy to be associated with a well-known engineering college back in India called KPR Institute of Engineering and Technology. I would love to introduce our speaker today, Mr. Vasant Sheelan. He is a professor, Department of Mechanical Engineering, KPR Institute, and he's also head of international relations. Welcome you, sir, for this session. We are glad to host you today for our career sessions.
Thank you for the introduction. Good evening to one and all present here. Thank you for Mindtree Quite for providing me a good opportunity to expose what is the 21st century engineering skills in mechanical engineering. Let us go to the today's topic. So how mechanical engineering has evolved. So I just given a small simple representation for you. This is a small comparison. In 20th century, the mechanical engineering seems to be contemporary traditional one, and now it has been evolved to the different view. You can see that from the left side to right side. I just given a small cartoon for your easy understanding. Without mechanical engineering, no field is complete. Right from artificial intelligence and to the materials engineering, all the leading engineering fields requires the basics and fundamentals of mechanical engineering. As we have shown here, right from the computer science, civil, chemical, electrical, and electronics and communication. So here, whatever the field you choose in this modern day, there will be an application of mechanical engineering in every corner. So let us see what are the opportunities that are evolved with mechanical engineering now. In earlier, mechanical engineering is known for its design and their machining and the services that we have shown here. In initial stages, the mechanical is completely known for CAD designs, CNC works, and industrial engineering, safety designs, and materials. Whereas now, the mechanical engineering is evolving and booming to the next level in the field of engineering. We can see that right from the automation, the industrial automation is the key role which is in line with electronics and the communication engineering. So that followed by non-destructive testing, one of the advanced technology that we employ in every manufacturing industry, followed by robotics, without which the no industry is growing and booming, and drone technology, also known as unmanned urban vehicle or unmanned aerial vehicles. This drone technology evolving in a higher way, in a different way, so that one who enters this drone area will be experiencing a different level of engineering, mechanical engineering with this. It employs both mechanical engineering structural designs, and also it employs electrical, electronics, and communication engineering too. And when we are with the Middle East country, the more focus will be on oil and gas industry. Yes, mechanical engineering has the room for oil and gas engineering, also for MEP solutions, mechanical, electrical, and plumbing solutions. You have plenty of opportunities to explore the oil and gas industries through mechanical engineering. And then IoT. Yes, the mechanical engineering is now moving towards IoT, that is industrial IoT, Internet of Things with industry. Most of the industries are now requiring IoT operations. Since in this pandemic, it will be helpful for any mechanical engineers to operate the industries and the manufacturing units and etc. using Internet of Things. When coming to the prosthetics, it is an application of biomedical engineering where you can produce and different structural organs for human bodies. Thus, prosthetics involves material selection, designs, and whatever the additional things requires, even the surface finishing, everything comes with the mechanical engineering. And then it's a hyperloop, one of the fastest mode of transportation that is ever that I have seen in the earth in the road mode. In the road. This hyperloop has been designed in such a way to meet the fastest transport, and this has an application of mechanical engineering. And then now satellites. for which the satellites that needs a launch vehicle. These launch vehicles will be designed by a mechanical engineering that is in line with aeronautical or aerospace engineering to propel the vehicle through the to the space and to design the satellites in such way it can help the next generation to survive in this galaxy. And then composites, where whatever the things, whatever the materials which you see, touch and feel is completely a materialistic one. This composites is one of the evolving area in mechanical engineering. Also it helps us to design a different material that can survey all in the earth, also in this space. This is also one of the most emerging area in mechanical engineering, followed by defense. Yes, when we comes to the any country or any organization, there comes the defense. Mechanical engineering has the vital role to play with the defense, right from the I said the drones. The best example will be drones and the automation. Both are employed with the defense. Nowadays the defense equipments are made to be it's self-sustained one within its own country, and it has high concern with that. Even mechanical engineers are hired at higher position in the defense, followed by blockchain technology, one of the most hottest plays in computer science engineering, but it plays a vital role with the aid of mechanical engineering, followed by 3D printing and 4D printing. We have 3D printing, it's also known as additive manufacturing system. This 3D printing helps us to produce a prototype without damaging the existing, or means, I mean, with the help of this comparison to that of NDT, in non-destructive testing, the vehicle or material will be damaged to test its worthiness, whereas in the 3D printing or 4D printing, it will be taken into additive manufacturing system where the process will be predefined. And there comes the electric vehicle, one of the hottest place, and the complete automobile industry is now focusing on electric vehicle. Whatever the country, whichever the place you choose, the electric vehicle brings up the plenty of opportunities for the recent mechanical engineering. From this, you can see that from the left side to the right side, right from the CAD, computer aided designing, and normal designing of any component on a vehicle, lathe CNC comes under machining of the process. We was in the era in the 20th century and the earlier of 21st century, we were lying with conventional vehicles. From the conventional vehicles, we have been transferred to electrical vehicles, which is now the current trend. So we can easily compare that. In the left side, you can see the traditional way of mechanical engineering, whereas in the right side, you can easily see that how the mechanical engineering is evolved along with the other engineering core subjects. Without a mechanical engineering, yeah, it will be added essence for you to survey in this competitive world. So how it is going to club? Why? What is mechanical engineering? Because we can see this basic thing. It contains core concepts plus computer aided engineering with added to product lifecycle management. What is meaning for core concepts? So whatever the process or whatever the thing which we usually do requires and core concept, how it has to be processed, how it has to be done. This is known as your core concept. For example, just take the 3D printing. In the 3D printing, it involves computer aided engineering, core concepts, and product lifecycle management. That means the core concept is what is the function that product has to be applied or image has to be done. Then is computer aided engineering. I'm just going to design that concept with the aid of computer aided, and I'm going to visual it visually, followed by product lifecycle management. So I'm going to define how this product is going to be sustained for the specified period of time. This three basic things brings out an idea within you. This idea will pay you and way to find out these things automatically. So right from a Hyperloop, drone, robotics, NDT automation, everything lies in line with core concepts, computer aided engineering, product lifecycle management. So these three implies these outputs, and it brings out the mechanical engineering in line with other essence of engineering. So when you take the mechanical engineering, we can see few core career paths. These are the core competencies in mechanical engineering, which will have its product life cycle, or else it will have its sustainability over the period of next 2 decades. The first one is automobile. It's one of the evergreen career pathway that can choose with an mechanic as a mechanical engineer, right? So automobile, from the conventional to electric, from the electric we are going to supercars, and we are developing the special vehicles for the special purposes. So we have many managerial concepts in line with automobile to make it sustain for a ever time, up till the presence of a human races. There will be a presence of automobile industry. And next is biomedical. As I informed earlier, this I have shown you a prosthetics. These prosthetics are artificial replacement for the natural limbs. For example, limbs in the human bodies are legs and hands. This will be once it is we got damaged, we cannot be replaced with the natural one. So in the biomedical engineering, in the aid of designs and materials from mechanical engineering, we create the prosthetics. These prosthetics can be 3D printed. Also, it can be they are devised by additive manufacturing or conventional manufacturing methods using composite materials. So this is the main application of mechanical engineering for biomedical. When you go for a material processing, most of the industries are concerned about wasting the materials and making they are not ready to make the environmental pollution. So with this, the material processing plays a key role where the wastage can be reduced and optimized to complete utilization. And this material processing complete unit works under the support of electronics engineering in addition to hydraulics and pneumatics. So this mechanical engineering system, this electromechanical system, micro-electrical mechanical systems will be completely coordinated with the aid of a mechanical engineer. And then robotics. Everyone will be very keen about the robotics. This robotics and automation is going to be the next, will be going to rule the next era for the at least for next 50 to 60 years. This robotics requires its own system to be designed, and this own system will be required for a particular applications. So for the in the few places, for example, nuclear industry, where the employing human is highly a risk factor. So in these places, robotics and automation will be employed to carry out the risk jobs. So it will be helpful for the humans to get or avoiding the dangerous works to be employed. And as I said, manufacturing, it is in line with material processing. So whatever the things which we use and which we employ needs a manufacturing unit. Here the raw material is completely transformed to a usable material. So this manufacturing unit will be nowadays it is getting evolved completely, as said, by 3D printing. It's also a type of a manufacturing technique. Usually we use a subtractive manufacturing. That is, the whole raw material is reduced for the required process, required material or required outcome. But in additive manufacturing, in 3D printing, material is added. It may be in a metal form or a plastic form. The material is added and material utilization is also confined without any wastage. And then as said, we have defense. In the defense, now the key roles are drones, and the next step is connected drones. We are also urban vehicle. It's now it is in a booming area in our mechanical engineering. It is also a part of a transportation engineering, so which has a good scope in the near future. We have few other new frontiers in mechanical engineering. One is micro electrico mechanical systems. This micro electrical mechanical systems have its own application with have its own application with robotic and automation, where the minor or small level electrico mechanical systems were coordinated in such a way to complete the process. And the next one is nanotechnology. It is in the application of medical field, nanotechnology, biomechanics, everything are there in line with the medical field. Even the medical instruments and medical supplies which we designed are in line with your mechanical. So what we do at KPR IIT? So we are in line with what are the new frontiers of mechanical engineering. We have Center for Machining and Material Testing. With this center, we constantly doing the new researches, and we are producing a new natural composite fiber combinations so that it can serve the future human community for our special purposes. And this laboratory is completely as a special laboratory established by KPR IIT. So with this, we are we have produced different types of materials to the different applications, right from the automobile application to the biomechanics, also for the prosthetics. We here design the materials for the same application. Then we have Center for Robotics, and it is one of a kind center that is present in this nation, also in the especially in Tamil Nadu. This Center for Robotics is powered by LN, right? Lucas Noel. This Center for Robotics completely nurtures the students' skills that requires robotics and automation for industries. This center mainly focuses on industry requirements. And then 3D printing laboratory. We have some 4 machines for 3D printing laboratory. Also, we have SLA. We have the SLA machines, which uses lasers to 3D print the objects. Students have been given free-handed with these laboratories to develop their own skill in 3D printing. Our students have designed few products that has been given to participation at national level competitions, especially in Toyota 2021 is the very recent place where our students has participated and uses these centers also. And then mechatronics laboratory. Mechatronics is one of the basic and fundamental laboratory that we have at our institution. This mechatronics laboratory helps to design micro electrical mechanical system and nano electrical mechanical system, hydraulics and pneumatics, application of these systems with any one of the mechanical fundamentals. And Center for IoT. Yes, with the nowadays industries are becoming IoT, it helps us to reduce the human intervention too. Also, it supports us in this kind of pandemic areas. The Center for IoT is established in line with an industry requirements to meet out the requirements of future engineers. We have diagnostic and therapeutics laboratory, and this we have been established with biomedical engineering. It paves the way to as discussed earlier. It paves the way to bring out the advanced prosthetics and equivalent to an human body, additional limbs. So the researchers were going on these areas at our diagnostic and therapeutics laboratory. So these are again major thrust areas. The product development. It is one of the major concern where the students are required to learn more. This will bring out an entrepreneurship. Few IITs are nowadays insisting their doctoral candidates to bring out the product development and to establish and start up to get their doctoral degrees. Why it is that much important? So the product development is the place where serves the needs of consumers. So we can get the particular needs of the consumer to support the product development. And then automobile engineering, as said, we have been transforming from conventional to electrical vehicles. Even those electrical vehicles are nowadays supported by supercapacitors. These supercapacitors stands as a starter and gives the highest torque or thrust for any electrical vehicle to start. So this transformation is bringing out the more avenues for students to explore in automobile engineering. In early days, there will be more than 50 subsystems in the automobile engineering. Even nowadays, the electronic vehicle which we are using, it requires more than 50 ECUs for a higher end luxury cars. at least 5 ECUs for an average car that we use from daily day to day. At the end, we will be learning out how the onboard diagnostics are there with the vehicle and how the subsystems are getting coordinated with the vehicle. In the upcoming days, the electrical will have some very few subsystems to coordinate all these activities. So this electrical vehicle in automobile engineering will be the best in the next few days or few years. And HVAC, yes, we have skyrocketing buildings is getting established everywhere. So the air conditioning becomes the biggest challenge in the skyrocketing buildings. So HVT, heat ventilation and air conditioning is one of the prominent area where the thermal engineer plays the vital role. So we have discussed industrial automation and material science. Though we have the special laboratory, students will be given with the opportunity to learn in the industry environment through internships and major projects. So this short note, I just give a small thank you for one and all present here for giving me an opportunity. So it is a short session. I just share the major things to you and upcoming avenues for the students to explore with mechanical engineering. Now the forum is open for queries.
Mr. Apparao, do you have any questions to ask Mr. Vasanthashilan?
Mr. Vasanthashilan, good evening. Thank you so much for a briefing.
Yeah, good evening.
Hope my voice is audible.
Yeah, sir. Yes, yes.
Yeah, maybe one or two questions from my side. Role of robotics today in petro or hydrochemical plants. How you really take on as a mechanical student?
Yeah. Here the center we have Lucas Newell. It is one of the kind center that I have said earlier. Here the students will be trained how the exact industrial process is there. So it has an exact industrial IoT model. So students can optimize the inputs and they can get the exact outputs, how the industry is functioning. So students can get easily trained with this industrial automation center, and so that they can be easily employed with the oil and gas industry or else any kind of manufacturing industry, which employs robotics and automation.
Great. As we understand that a mechanical engineer is a mother of all engineering sects, I guess. Definitely mechanical students will have a far better edge comparing with the rest of the things. So in this regard, I think petrochemical industrial zones probably prefer mechanical engineers, right?
Yeah, because there will be always a requirement for MEP solutions.
Mm-hmm. So in this regard, anything that advanced courses or something like that, once they complete the BTech mechanical engineering, where they can able to relate themselves to this petrol, oil and gas industries.
In line with this point, the facilities which we have at KPR-IT and our syllabus and the curriculum have been designed in the way from industrial inputs. So there will not be requirement of any special courses to be studied separately. When it comes to the action from any other institute, definitely they need to go for any other special courses. I can say an example. We have non-destructive testing at our institute. This course has been taught by the experts from L&T. So they will be coming to our campus and they will be taking care of this course. So there will not be any need for a student to get a special certification from any other agencies. So he will be trained further by the industrial person at our institution. Similarly, we have some other skill courses for HVAC and robotics automation and even electronics, that is automobile electronics for onboard, especially for onboard diagnostics. So we have few other more skill courses that will make the student complete mechanical engineering and he can be directly employed with an industry.
Very good, very good, very good. Thank you so much, Mr. Vasant Salem, for the comprehensive talk and the use of being a mechanical engineer in today's world. Thank you so much.
Thank you.
Thank you.
Over to you,
Thank you,
Mr.
Mr.
Chaudhary.
Seelan. Thank you so much
Thank
for a
you.
wonderful session. And thank you, parents and students who are watching us live through our social media platform. If you find worth this information sharing, please do share it with your friends and families. And those who would like to know more about career opportunities, getting admissions in mechanical engineering, please do get in touch with our Mindtree team. We'll be happy to help you. Thank you very much. Have a good evening.
Thank you.